Hello ladies and gentlemen, this is Miss Skokan. We're back for another video lesson, this time on section 3-2, multiplying polynomials. And remember that you have the assignment of reading your textbook section as well as doing some problems after this for practice. So fill out your notes as we go along. We've got a warm-up to start with, so pause the video and multiply these monomials to each other. It's a multiplication of monomial to monomial. Turn the video back on when you're ready to check your answers. All right, hopefully you were able to get all of these perfectly, and if you didn't, pause the video now so that you can go back and take a look and see what you might have done wrong. Remember that we have exponent rules that we use, so if you need a little refresher on exponent rules, there's one coming up. And when you're ready to continue the lesson, taking a look at the objectives and the vocabulary, turn the video back on. Okay, so here we've got our objectives: multiply polynomials and use the binomial expansion to expand binomial expressions that are raised to positive integer powers. So we will be doing both of those things in this section. You will find that there's another way to do the binomial expansion. We'll take a look at that later this year, but for right now we're going to be using Pascal's triangle, which you saw at the end of our section 3.1 notes. Okay, so how do we multiply polynomials? What we're going to do is we're going to use the distributive property and the properties of exponents. You'll notice in your notes that there's a little bit of a review. Again, take a look at that if you need to. Otherwise, let's press on. In example number 1, we're multiplying a monomial to a polynomial. And what we're going to do, you can see that this is set up just like the distributive property. We are going to use the distributive property, and what that means is each monomial is going to be multiplied to each of the terms inside the polynomial. We're going to combine like terms and come up with a final answer. So pause the video now so that you can try example A out. All right, hopefully you tried it out and did well. Let's take a look at how this works. We first distribute, combine like terms, or multiply and then combine like terms if there are any, and we come up with a final answer. We've got another example, example B. Again, pause the video so that you can try it out for yourself. Turn the video back on when you're ready to check your answer. All right, for example B, we needed to multiply through, that's distributing that FG term. And after we multiply, if there are any like terms to combine, we'll combine them for a final answer. Now, one thing, when we've got two different variables in a term, such as the f and g, what we're going to need to remember is that for like terms, the powers of each one of those variables has to be exactly the same. All right, let's move on to the next example. To multiply two polynomials to one another, we need to use the distributive property, but it's going to feel a lot more like a FOIL than it is the distributive property. We know that FOIL actually is the distributive property, but it's just done twice. Well, this time we're going to use the distributive property however many times we need to, so that each of the terms in the first polynomial can be multiplied by each of the terms in the second polynomial. Make sure to stay organized, kind of come up with a system for yourself, like the first one times the first one, then the first one times the second one, then the first one times the third one, and then go on to the next term in the first polynomial. But stay organized. And just a little reminder so you can check yourself. However many terms you have in the first polynomial, in this case 2, times however many terms you have in the second polynomial, in this case 3. So 2 times 3 gives us 6. We're going to end up with 6 terms to combine. Excuse me. And remember, we can only combine like terms, otherwise they're going to stay as separate terms. So let's take a look at an example. All right, here you have a binomial multiplied by a trinomial. We're going to multiply that through just as we saw in the instructions on the previous slide. Pause the video now so you can try it out yourself. All right, let's check your answer. First thing we do is we're going to multiply this one. This is a method that we use, multiply horizontally. This is what we've been doing. and we multiply each term to each term in a horizontal way, meaning along one line of our paper. And when we're done with the multiplication, we combine like terms if possible and come up with a final answer. Whoops, sorry about that. Come up with a final answer. All right, let's take a look at another example and possibly another method. Actually, what we'll do is we'll take the same example and use a different method. Okay, so same example we were looking at a minute ago. This time what we're going to do is we're going to multiply vertically. And this is going to look like the long multiplication that we learned, I'm guessing, in 3rd grade. So you're going to set it up so that you have one term on top, or one polynomial on top of the other polynomial. Okay, so each one of them is written in standard form, meaning by decreasing degree. And the longer one, in terms of number of terms, is on top. The shorter one, with fewer number of terms, is on the bottom. But they're lined up so that they have the same degree in the same column. Then we're going to multiply one at a time. And really this is doing the same thing as our horizontal multiplication, but it's just in a different visual way. If this appeals more to you, you can use this method. If the horizontal appeals more to you, because that's what you're used to, then you can use that method, no problem. But you can see that what we're doing here is we're multiplying each term by each term, and once they're set up in columns, it's very easy to combine like terms, and that's the benefit of this method. So once we've got that combined, or like terms combined, we have a final answer. All right, we've got another example in our notes, and you can use a third method for this one. And this is, I know some of you use this method for multiplying. You probably learned this in Algebra 1 or possibly before in elementary school for long multiplication. And what we're going to do is we're going to set up a kind of a matrix. And one polynomial is going to go across the horizontal, the other polynomial is going to go down in a vertical direction. And we're going to multiply term by term in an organized way so that we can see on the diagonals we have our like terms. So it's very easy, again, to combine like terms this way. Very easy to not lose them because we know we're combining along the diagonal. And this will give us a final product of the two polynomials. If you need to pause this to take notes on it, please feel free to do that. And once you combine like terms, you've got a final answer. Okay, let's take a look at a real world example. And in this case, we're looking at a burley box, which is a box that you use to carry documents. And it's P feet by 3P feet by 4P feet. And you have a little illustration in your notes. You can see that it's a rectangular solid. And in this situation, we have a large burley box because there's a standard size that we just got the dimensions, and then the large version is added 1.5 feet, 1.5 feet to each one of the dimensions. So you're going to write a polynomial v of p to represent the volume of the burley box. You're going to write it in standard form, so that's by decreasing degree. How are we going to do this? Well, what we're going to have to do is expand out this idea of volume as the product of the three dimensions, length times width times height, and include that 1.5 additional feet in each one of the dimensions. So in this example, it says it's area of the base times the height, and the area of the base is length times width. So what we're going to be doing is multiplying length times width times height, and each one of those is going to be the original dimension, P, 3P, and 4P, added to each one of those 1.5. Okay, so here when we're multiplying the polynomials to one another, again, we can do this vertically, horizontally, or using the matrix. And once we've got the intermediate product, we multiply by the remaining dimension. And what does this mean? This is another way of saying When you have three polynomials, in this case they were binomials, when you've got three or more to multiply, you can only multiply two at a time. So you're going to multiply two at a time and then multiply by the remaining ones. Again, two at a time, two at a time, two at a time. And once we get this all multiplied out, we combine like terms and we find our volume of the Burley box. Just as we've seen, we can multiply polynomials to each other, multiply monomials to each other, multiply polynomials to monomials. Well, we can also raise binomials or polynomials. We can raise to powers. In this case, what we're going to be doing is we're going to be taking a binomial and raising it to a power. You can see in the example we have a plus 2b cubed. And just as we said a minute ago, when we have different polynomials to multiply to one another, we can only multiply two at a time together. So what we're going to do is show this as the expanded product a plus 2b, and we're going to multiply three of them to one another. That's what that exponent 3 means. So that's the very first thing that we're going to do. The next thing that we're going to do is multiply two at a time using our FOIL. And if you memorized the pattern, as I've recommended previously in class, you know you don't exactly have to FOIL. You can write out the pattern. And then what we have is we have a binomial multiplied by a trinomial. And what we've done is we've multiplied two of the binomials together, giving us now only two different polynomials to multiply. We're going to multiply these two polynomials together, as we saw in some of the previous examples where you multiply the a to everybody in the second polynomial and then the 2b to everybody in the second polynomial. Okay? So once we've expanded this out, the multiplication is actually going to take place. Once they're multiplied out, we're going to combine like terms and come up with a final answer. This next example is not in your notes, but I just wanted you to see it very quickly. You can see even when we're raising it to the fourth power, we're still only multiplying two binomials together at a time, and then multiplying the remaining or the resulting polynomials to one another, and then combining like terms until we have a final answer. Sometimes there's a little bit of a shortcut, and if you notice the powers, or the coefficients that we came up with when we expanded that power of a binomial, you'll see that the coefficients match Pascal's triangle. So pause here so that you can take notes on this, and then we'll resume with another example. Okay, so here we have some rules for the binomial expansion. Again, you need to pause the video to take notes on this. And you do have this in your set of notes, but you are going to want to make sure that you have a good understanding of these different rules. If you don't, put a post-it note in your notes with your question, and we'll go over them when we're in class together. All right, let's take a look at example 5, and here we're going to be using Pascal's triangle and the list of coefficients to expand the binomial expressions. What's going to happen is we're going to first look at the power. Once we know what the power is, we're going to get the coefficients from past the appropriate row. So remember we started counting with row 0, then row 1, row 2, and row 3. Pull the coefficients out, and then we're going to multiply in a pattern that starts out with the first term raised to the power 3 and the second term, -5, raised to the power 0. Then we're going to knock down the 3 one by one by one. So first 2, then 1, then 0, and increase the other power, first 0, then 1, then 2, then 3. Multiply those together and then combine like terms as necessary. Pause the video here so you can try example B yourself following this pattern. Okay, if you had any trouble with example B, pause the video, go back and try again, remembering the pattern. Take a look at the rules and remember, first thing, using the exponent, go to the row in Pascal's triangle, use that for the coefficients that you see here in red, and then we have the pattern of exponents. Again, follow the pattern. Here we have a little lesson quiz. Pause the video, try each of these problems, and turn it back on when you're ready to check your answers. That's it for lesson 3-2. We'll see you back for lesson 3-3.